Okay, welcome to this video on testing for halide ions. So let me just make this clear then. This is halide ions in solution, and a halide ion in solution is either a Cl- aqueous ion, a Br- aqueous ion, or an I- aqueous ion. These are the halide ions that you need to know a test for. So the way that we test for halide ions, so if you have a beaker and into that beaker you put a solution or some water or whatever, and you suspect that it's got a halide ion in, so you suspect that it's got some X minuses floating around in there, but you don't know what halide ion it might be. You think it might be chloride, it could be bromide, or it could be iodide, but you're not sure. So imagine now, please do imagine this, you've got a beaker, and hang on, I've got something here. That's a jam jar full of mucky water from painting. But you think, oh, I think there might be some halide ions in there. So you've got a big beaker and you go, right, how do I test for that? Well, you also need to remember that in here there'll be some H2O liquid. If there's some X minuses, some chlorides or whatever, there'll be some other ions as well. So maybe some sodium pluses or whatever. So you'll have a beaker full of ions. But what we're looking at here is how do you test for this? And the test is really, really simple. So on a very, very simple level, what you do here is you put in some silver nitrate solution, some AgNO3 aqueous. Now, you also need to know that to make this test work better, you do need to add some nitric acid as well, some HNO3 aqueous. That just makes it work better. But if we were in the lab here, I'd show you silver nitrate works fine, but also you need to add some nitric acid. So things that we need to work out is what's going on with these reactions. Also, why do we need to add the acid? So we'll be looking at that in a minute. Okay. What I will tell you now then is silver nitrate, AgNO3. As soon as I put this state symbol aqueous, what that means is this silver nitrate is in solution. And when silver nitrate is in solution, it's an ionic substance made of silver ions and nitrate ions. So you can think of silver nitrate as actually being Ag pluses and NO3 minuses. So AgNO3 aqueous is silver ions floating around in solution and nitrate ions floating around in solution. HNO3 is aqueous. This is made up of H plus ions and NO3 minus ions. So H plus ions aqueous and NO3 minus ions. The NO3 minus ions are not important in any of these reactions, the nitrates. What are important are the silver ions and the acid ions, the H pluses. So what I'm going to look at now then is why we add silver nitrate. I'm going to put the acid to one side for a minute. We'll talk about that shortly. But I'm going to go focus on what you need to know. What happens when you add silver nitrate with a bit of nitric acid to a beaker like this? All right, and it's very, very simple. If the halide ion is chloride, bromide, or iodide, you will get a different result. So what happens is, if you've got the Cl minuses and you add silver nitrate, now notice what I'm doing here, I'm already ignoring the nitrate bit because it's not important. So what happens is, the silver ions from your silver nitrate ions will react with the chloride and they will make AgCl. If you write AgCl2, I will hunt you down. All right, it's a really common thing. People love to write AgCl2. It's not that, it's AgCl. And this is a white precipitate. White. And it's a precipitate. So you have to get used to writing solid next to it. What that means is, as soon as you put the AgNO3 in, you will see a white solid appear. It will look cloudy in there and it will settle to the bottom. It will be a solid. You will be able to filter it out because it's a precipitate. It is solid. You can filter it. Okay, if you have bromide ions in there, if your X minus in this beaker is a bromide ion, and you do the same experiment, you add some silver nitrate, some silver ions in solution. Let me just write the state symbols down because I need to be specific here. So if you have some bromide ions in there and you add some silver ions from some silver nitrate, you will make AgBr solid, which is a cream precipitate, which again, if you wanted to, you could filter it out. If you have I minus in there, iodide ions, and you add some silver ions in the form of silver nitrate, you will make AgI solid, which is a yellow precipitate. So you need to know that you will make white, cream, and yellow. And this is very much GCSE standard. You will make a white, a cream, or a yellow precipitate. The nitrates are not important. So what we have here are 3 equations, and each of these equations are described as being an ionic equation because we have missed out the ions that aren't getting involved because we're not interested in the nitrate ions. We're not interested in the sodium ions or whatever. We're just interested in silver ions meet chloride ions to become AgCl, which is a white precipitate. All right, that is not hard to learn. I often summarize it like this. Chloride in lessons, if I was in lessons, chloride, bromide, iodide, I would just write Ag plus and I'd go white, cream, yellow, and I would expect you to know what this little diagram meant, white, cream, yellow. On the periodic table, there they are on top of each other. Chloride, white, cream, yellow. There is a progression here. Imagine somebody has got white, perfectly white teeth. The next one down, a little bit creamier. Maybe they need to brush their teeth more often. And then yellow teeth. It's getting more and more yellowy as you go down. White, cream, yellow. You can also remember that chlorine bleaches things. It bleaches things white. So as long as you remember that chlorine is white, then all you've got to remember is white, cream, yellow, and you'll have it sorted in your head. All right. So chloride and silver. Now here is the thing that a lot of people get confused about, because at A level you need to know a little bit more about what to do next. What happens next is that in reality a white, a cream and a yellow precipitate all look remarkably similar. If you have one on its own and not anything to compare it to, they all look a little bit off-white. So we could do with a follow-up experiment to test which one is which. And so there is a follow-up experiment that we do. Once we have added the silver nitrate and we get these precipitates, what we can then add is ammonia. So this is where ammonia comes in. All right? And what you will find is that silver chloride will dissolve in dilute ammonia. It will dissolve in dilute ammonia. But silver bromide will only dissolve in concentrated ammonia. And silver iodide will not dissolve in any ammonia at all. So if your white precipitate dissolves, you will end up with a colourless solution with dilute ammonia. Dr. Halide has put on her sheet what actually happens. The silver becomes something called AgNH3 twice, plus it dissolves, and the chlorides are kicked out. I'm not that interested in this bit yet. I just want you to know that you add silver nitrate to get white, cream, yellow, and the next thing you do, if you're not sure whether you're looking at something white, cream or yellow, is you could add a little bit of dilute ammonia to it. If it dissolved, you know that you've got chloride. If it didn't dissolve, you're dealing with bromide or iodide. So your next step is to add concentrated ammonia. If it dissolves, you're dealing with bromide ions. If it doesn't dissolve, you're dealing with iodide ions, because that's that one. So my little diagram goes, I want to test a little beaker that I think has got chloride, bromide or iodide in. Step 1, add silver nitrate and nitric acid. And then the follow-up step, which is the A-level step that you didn't know until now, is to add different strengths of ammonia. Dilute, concentrated, and it won't dissolve at all. And you will get dissolve, dissolve, no dissolve. So this little mnemonic down here, if you understand it, is very, very useful. All right. So the next thing to say is, well, why do we need to add the HNO3 at all? If it's just the silver ions reacting with the halide ions, what is the point of the HNO3? And you need to understand this. All right, so why do we need nitric acid? All right, so imagine then that you've got a beaker and you're convinced that it's got some halide ions in. All right, so you put some silver nitrate in there and you might well get your white, your cream, or your yellow precipitate. But here is a fact that you need to know. Sometimes a sample of water can have carbonate ions dissolved in it too. And these carbonate ions can create a bit of a problem, because when silver ions meet carbonate ions, CO3 2-, you can get some Ag2CO3 formed. So you'd need two of these aqueous and one of these aqueous, and you can form silver carbonate, which is a white precipitate. So imagine that you've got a beaker of water and it's got some, some bromide ions and some carbonate ions. You would get a white precipitate formed and a cream precipitate formed, and you wouldn't know what was going on. I suppose more clearly, if you had a sample of water and it didn't even have any halide ions in, and you put some silver nitrate in with just like that, you would make a white precipitate, and you would go, yay, I've definitely got chloride ions because I've got a white precipitate. But you haven't. You've just got carbonates. So the question was, why do you add HNO3? And the reason is you add your HNO3 first because nitric acid, being an acid, reacts with carbonates. It fizzes them away. So if they ask you in an exam, why do you add HNO3? The reason is this, because HNO3 contains H+ ions. The H+ ions react with the carbonate ions to make H2O and CO2. It fizzes the carbonate away. Gas, liquid, aqueous, and aqueous. The H+ ions react with the carbonate ions to make water and carbon dioxide. I need to balance this. Two of these. Now, because you add the HNO3 first, you get rid of the carbonates, because carbonates can give you what is known as a false positive result for chloride ions. They give a false positive, which means they give you a white precipitate and you will go, oh, that means there's chloride, whereas it might not have meant there were chloride. So, in summary then, if you want to test for chloride, bromide, or iodide ions, you need to add silver nitrate, Ag+, which contains Ag+. I'm not bothered about the nitrates. And you will make AgCl, AgBr, and AgI, which are white, cream, and yellow. White, cream, and yellow will dissolve in dilute ammonia, will dissolve in conc ammonia, will not dissolve in any ammonia, and these will give you a colourless solution. I'm just going to write solid there, and solid there because they're a precipitate that you can filter. And these are all aqueous ions. And then if I go back a step, before you do any of this, add HNO3 to get rid of the carbonates, because two H+ will react with the carbonates to make carbon dioxide and water to stop the false positive. I hope that makes sense to you. I hope that's now clearer for you. And I hope that now when I go through the questions in the next video, you will understand this a little bit better. Okay, thank you very much. I do appreciate any feedback you can give me on these via emails. I know I go through these quickly, but you can, you are doing it with the notes in front of you as well, so you can see some notes. Dr. Halide presented this as a table. I think this is a nice little way of remembering it as well. So let me know if you need any more help with this. I don't mind doing it. This one's only taken me 15 minutes, so it didn't take too long. All right, good luck with it.